Alright, so we're warming up some water. I pulled the thermostat out. Doing this heat in stages because you have a 160 stat. Put this up in there. Submerge the thermostat. Doesn't need flow, it just straight works off temperature. So when it warms up to a certain point, there's just a valve that opens. So we're at I don't know, 180, 185. So you can see that gap in there. So thermostat's opening. So you could slap new parts in, put used parts in things, and then you're guessing is it working or not. It's a good way to test stuff. So we're at 180, so what we could do is we could watch it close and see what temperature it actually closes at. So sitting at 180, this thing's got a pretty big gap. You can see that valve's quarter-inch gap there. Now watch as it cools down, that gap will close. So you can actually see it closing. Alright, so it opens and closes. And the way you know it's a 160, by pulling the damn thing out. That's it. 160. Water's at 180. I'm going to drop it back in. See that opening up down here? Temperature's 175-ish. So it was a nice cool temperature for Florida. Let's put it that way. Alright, what I did notice is there's no bleed hole anywhere in these. So what happens is you have no flow at all until this valve opens. But that means that the temperature of the coolant in the engine may not reach this fast. So what happens is the water on one side of the engine will start warming up, but if it's not flowing even a little bit, it won't even move towards this thermostat. So what we end up doing is drilling a pinhole in this, just so that the water can move through it, even just a little. And that allows the temperature to even out in the cooling system better. So I'm gonna drill a little hole in this just to let it bleed, and I'll put it back in. But again, just one more thing I wanted to test before you know, being able to give this back to you with a clear conscience saying I checked everything.